Hello, I am Cami Miller, and for my project, I'm going to be talking about hereditary hemorrhagic telangiectasia, or HHT. What is HHT? HHT is a disorder that results in the development of multiple abnormalities in the blood vessels. HHT are some arterial vessels flow directly into veins rather than into the capillaries. These abnormalities are called arteriovenous malformations. When they occur in vessels near the surface of the skin, where they are visible as red markings. They are known as telangiectasias, or singular is telangiectasia. Without the normal buffer of capillaries, the blood moves from the arteries at high pressure into the thinner wall, less elastic veins. The extra pressure tends to strain and enlarge these blood vessels and may result in compression or irritation of adjacent tissues and frequent episodes of severe bleedings or hemorrhages. Major characteristics or physical effects signs. Nosebleeds are very common in people with HHT, and more serious problems may arise from hemorrhages in the brain, liver, lungs, or other organs. Nosebleeds often are caused in the early childhood, and sometimes they happen on a daily basis, which leads to iron deficiency. Iron deficiency can happen due to having so many nosebleeds. You're losing a lot of blood. You become very iron deficiency. You also have lacy red vessels, which are tiny red spots, particularly on the lips, face, fingertips, tongues, and inside of the mouth. Some other symptoms of HHT are shortness of breath, headaches, and seizures. Okay, so for the molecular cause, there are different types of HHT, but those types are affected by different genes. In this case, they are affected by the mutations of endoglobin or ENG gene. This one is located on the long arm of the chromosome and is located on chromosome 9. Okay, so for mode of inheritance, HHT is a dominant allele, which makes this an autosomal dominant trait. It is inherited from one of its parents. If one parent has HHT, they have a 50% of passing it down to their offspring. Same goes for their child. If they are also affected with HHT, they go to have an offspring, they pass it down and have 50% chance as well, and so on. Better understanding of this on the next slide. Okay, so inheritance. You have scenario 1, parent genotypes. You have big H, and big H parents. Okay, so then their phenotypes would be, both of them are afflicted. So then their offspring would be big H, and both would be afflicted for the phenotype, and then the probability would be 4 out of 4 equals 1 in 100% of afflicted offspring. So then for scenario 2, you have one parent that is big H, which is afflicted, and then you have little h, which would be normal phenotype. So then for their possible offspring of genotypes, they would have big H, and for their phenotype, it would be afflicted carrier. Their probability would be 4 out of 4 equals 1, 100% of offspring being afflicted carrier of HHT. And then for the third scenario, you have big H, and big H and little h, which would be afflicted and afflicted carrier for their phenotypes. And then you have, that would make their possible genotype of being half and half. So half would be big H, half would be big H, would cause the phenotype to be half afflicted and half afflicted carrier, which would make their probability be half and half, 50%, which would make this 100% afflicted. And then for the last scenario, you have the genotypes of both of them being little h, so then both parents would have the phenotype of being normal, and their possible offspring genotype would be h, and phenotype would be normal, causing the probability of a 4 out of 4 equals 1, and 100% probability of offspring being normal or 0% of being affected. Which then brings me to my pedigree. As you can see, I picked both the parents for the first generation to be afflicted, which causes them to have 2 afflicted kids and 1 normal. So on the right, you see Colby, he is normal, and if he has a wife that is normal, they are going to have normal children. For Shane, he's obviously afflicted carrier, so with him being a 50%, he's more than likely going to have kids like that. So he had 2 kids that are also afflicted carriers, and Lydia and Braden, had a child which is afflicted. And then same with Troy and Shanna. With her having 50%, having 6 kids, I gave them also 50% chance of having afflicted kids and normal kids. And as you can see, there are 3 and 3. And so then Braden and Cammie have 1 and 1, 50% again. So then on the bottom right, you have the inheritance pattern. And it shows about what each offspring would have if they would have another child. Okay, so then for genetic testing of HHT, molecular testing is a laboratory technique that involves analyzing a tissue, blood, or other body fluid samples to detect specific genes, proteins, or molecules that could indicate the presence of a disease or a condition. Molecular genetic testing is utilized to diagnose HHT or a related disorder in symptomatic individuals, pinpoint the specific variation in an affected family member, and test family members at risk. So then you have mandatory or optional. This is a mandatory because if parents have HHT, testing their children for brain and lung AVMs is mandatory unless genetic testing has already been ruled out. Sedatives or general anesthesia may be required for young children to get the testing done properly. If a family member has been identified to carry HHT mutation, genetic testing can be done on at-risk family members to determine who needs to be screened for the internal AVMs due to the condition. When is the genetic testing typically done? Determining the right time for genetic testing for HHT can be difficult because it can develop later in life. However, if you have received a clinical diagnosis of definite HHT, genetic testing may be recommended to identify the affected gene and test other family members accurately. If a direct relative has already received a genetic diagnosis, testing can be done to determine if the mutation is present or absent in the family member. If mutation is present, it confirms the presence of HHT, while if it's absent, it is ruled out. Early detection. HHT is a condition that can impact various organs in the body. Identifying it early is important. Ambulatory time interventions can reduce the risk of complications and fatalities. Signs and symptoms can develop later in life, but it is important to undergo genetic testing if symptoms are present. Identifying the HHT mutation through testing can lead to early detection and treatment for affected individuals. Tests can be performed on other family members to catch HHT early and provide appropriate care. The costs. The price of genetic testing can differ. The first examination can cost $2,000 or more to discover the affected family gene. After identifying the family gene, a test for another family member usually costs between $300 and $400. These are my references. I hope you enjoyed my presentation, and I hope you learned a little bit more about what HHT is. I enjoyed learning about it throughout this semester, and yeah, thank you.